The next thing we are going to discuss is the gravitational force. See, if you put any two objects near each other, they'll attract themselves, and they'll attract each other with some force. And Newton observed the properties of this force from astronomical bodies, and he deduced the following decisions. First is, the gravitational force is directly proportional to the mass of those two objects. So we'll write force proportional to m1. Let us say mass of this is m1 and mass of this is m2, and force proportional to m2. And this is an inverse square law force. The meaning of this statement is the force between them, that is the force they exert on each other, is actually inversely proportional to the square of the distance between them. So if the distance between them is r, the force is proportional to 1 by r square. So if we write them together, that gives us F varies as m1 m2 by r square. And from here we can make use of a constant F equals k m1 m2 by r square. But since we are doing the study of gravitation, we do not call this as k, we'll write this as g. And this constant g is universal, and this is called universal gravitational constant. And the value of g is 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. So now we'll solve a simple problem. The problem is, we have two masses, one is 1 kg and the another is 2 kg, and the distance between them is 50 centimeters. We are required to find the gravitational force that will be exerted, that they will exert on each other, and the acceleration of each body if considering another is at rest. So we'll just make use of this formula we have written here. So for the force between them is g m1 m2 by r square. So you see those are different units. This is cm, this is kilogram. Kilogram is standard SI unit, but cm is not, so we'll need to convert it to meter. So 6.67 times 10 to the power minus 11 times 1 times 2 by 50 centimeters means 0.5 meter. I'll just use a calculator to evaluate this. So that gives us 5.336 times 10 to the power minus 10 Newton. And the acceleration of them, considering the second object is at rest, we'll just find its acceleration as a equal to f by m1. You see this is unit mass, that is 1 kg, so the acceleration will be 5.336 into 10 to the power minus 10 meter per second square. And the acceleration of the second object is f by m2. We'll just divide this expression by 2, and this gives us 2.668 times 10 to the power minus 10 meter per second square. So this is the answer to the problem. I hope you like this video. See you in the next one.